data can be in any formats. The default for Python is the data frame. So this is the format that we require for processing this data using many libraries that are available in Python. Easy for Python to understand this data and process. Right. So from a data structures and algorithms perspective, DSA, data structures and algorithms. This is structure and algorithms. As I said, Python has many libraries. Now, when we deal with data, data comes in different file formats. It could be CSV, it could be JSON. You could directly connect from database tables. It could be XML, it could be HTML, it could be Sara file, Parquet files, it could be Avro files. So many formats are there. Python has the capability to read the data from all this and store into its sessions memory. By default, it comes in a data frame format, provided we have the data in these formats in an organized manner. So auto interpretation of the data types is done by Python. Dynamically, it reads that. But there are certain formats which cannot be directly loaded into a data frame format. And we have seen, right? For example, transactional data. That means every record is a vector. Every record is a vector, and we have collection of vectors like this. Now, vector size can vary. But for a data frame, we need to have a consistent dimension, right? This is not possible in transactional data. So this becomes list. Right? So this is a list. Now, in such cases, we have to do data manipulation, data pre-processing. A very important step. Data manipulation or data pre-processing, you can say. So depending on what kind of format the data is in, we decide upon certain data manipulation techniques to be applied onto the data, and ultimately we get the data in an organized, structured format. Again, which is nothing but data frame. And the values in the data frame should also be appropriate. They also have to be following certain rules, which of course also have to explain the business aspects that we are trying to solve. Data is ultimately representing business, right? So we will have to do all those manipulations on the data. So transactional data, again, here we can do transactional encoder or do simple one-hot encoding using get dummies or one-hot encoder libraries. This is one way. Ultimately, we need to get transactional data. Then what if I have graphical data? We're talking about graphs. A graph basically means interconnected entities. Like this, you'll have connections. So here we will have nodes, which are also called as vertices or vertex. Singular is vertex, plural is vertices. These are nothing but the nodes, right? You can just imagine these are your social media connections, and each circle is either you or your friends who are interconnected. Those connections are represented using the lines. Connections are, we also call them as edges. All right, so this is how a graph is represented. Again, it's a visual format, right? The data that you're seeing is in visual format. This is a network of interconnected nodes or entities, you can say. So a graph contains two elements, right? Two elements. What are those? Nodes and connections. So collectively, this becomes a network. So when you're trying to analyze this kind of data, we need to again try and understand the network and then process it. The first step in this is, how do we represent this in a table format so that I can use Python libraries for performing certain operations on this data. Right? So that's basically something that we need to look at. And here we call this representation as adjacency matrix. Ultimately, it's a two-dimensional object. We call this as adjacency matrix. All right. Which is, again, in a way, we see this as one hot encoding only. In a way, it is nothing but one hot encoding. We take the nodes or vertices here and here, rows and columns, and we represent the connections either as 1 or 0. 1 represent there is a connection, 0 represent there is no connection, like this. All right. So this is how we represent a network or graphical data in a two-dimensional object format so that Python libraries can be used for processing that. Then we have many unstructured formats that we need to also look into. Graph is, of course, unstructured data, but text data can also be in unstructured, and majority of the cases it is unstructured in nature. All right. So here also we will have to try and convert this into a structured format, a data frame. And for doing that, we again do data manipulation steps. Text data is like a very big sentence, so we try to chop it up. This is called as tokenization. We create tokens or words. And then we try to represent the tokens in that entire text data in a key and value pair, where the key represents the token or the word. Value talks about the frequency of that word, how many times that word is repeated in that particular text data. This representation is called as bag of words. And here we create multiple bag of words for each document, right? Each text data that we are breaking it up, right? The entire text data will be broken down into these documents, we call them as, isn't it? And for each document, we do this bag of word representation, which gives us a vector again. Vector representation for the text data. Collectively, when I put all these vectors together, we get a matrix, which is called as a document term matrix or a TDM, term document matrix. Right? So again, we will get the data in a structured format. So this is the underlying truth, whether it is an image data, whether it is an audio file, right? Whatever the format of the data is, whether the data is structured or unstructured, we need to do data manipulation and ensure the data is in an organized fashion for our computers, that is our softwares that we are using, are able to read the data and process it. Process again means nothing but we have a predefined set of algorithms that are available in Python. We should be able to use them to process our data, do some computations on that particular data.